Okay, so in this video, we are looking at Bernoulli trials. So what is a Bernoulli trial? So I'm going to set up why we may use a Bernoulli trial. So say, for example, I ask you, okay, if I were to flip a coin 3 times, what is the probability I will get 2 heads? Right? So I flipped a coin 3 times. What's the probability I get 2 heads? So what are my total combinations here? Well, I can get heads, heads, and tails. I can get heads, tails, and heads. Or I can get tails, heads, and heads. Right? That's how many times I can get 2 heads when I flip a coin 3 times. So the total amount of combinations here is 8. So the probability would be 3 eighths. Right? Because I have 2 outcomes, 2 outcomes, 2 outcomes. So I have 8 possible outcomes. 3 of my outcomes will have 2 heads. Right? That's an easy enough example, right? But what happens now, right? If I want to do this for larger values, say for like 10 trials. So say if I flipped a coin 10 times, how many times can I get 2 heads? That's when things get a bit crazy, because then I'll have 2 to the power of 10 possible combinations, right? Which is 1024. And I'm not going to write down all 1,000 combinations of me flipping a coin 10 times. Like, that's just, I'm not bothered. I am bothered, right? So that's why we kind of look at Bernoulli trials. So what is a Bernoulli trial? So a Bernoulli trial basically allows us to, how many times does something happen? We can calculate the probability of how many times something happens in a given number of trials. So a Bernoulli trial, in order to apply Bernoulli experiments, the following conditions must be met. So in order to do a Bernoulli trial, there are a fixed number of trials, right? The trials are independent and repeated under identical conditions. So that means if I fail the first time, that does not impact my success the second time. Each trial only has 2 outcomes, success or failure. And the probability of success and the probability of failure remain constant for all trials. So there's none of this, so the probability of like winning a hockey game, there's none of this, well, in the first game, I have an 80% chance of winning. But if I lose that in the second game, I have like a 60% chance of winning. So they're consistent, right? Every game you go into or every trial you do, you have the same success rate and same fail rate. So we can use the binomial distribution, right? This can help us model the number of successes in a fixed number of independent Bernoulli trials. So it gives the probability of having exactly k successes in n Bernoulli trials. So why do we do this? Well, we kind of think of it as, well, P is my success of success, Q is my success of failure, N trials. We kind of expand this out to find out, like, oh, how many times, when do I pass it 3 times, you know? So we have to use our binomial distribution for that. So it's N choose OR times P choose OR times Q to the power of N minus OR, where N is the number of trials, OR is the number of successes we want, P is the probability of success on a single trial, Q is the probability of failure on a single trial, and N choose OR is the binomial coefficient. So let's have a look at this here. An unbiased dice is thrown 5 times, right? Find the probability of taming 1/6, right? So we can get the 6 on the first throw, we can get a 6 on the last throw, a 6 on the third throw. We don't know. So it's just going to be N choose OR times P to the power of OR times Q to the power of N minus OR. So N choose OR, that's going to be 5. Choose how many successes I have. I'll have 1. I only want 1/6. P, what's the probability of getting a 6 on the die? Well, that's 1/6 to the power of 1 times probability of not getting a 6. 1 minus 1/6 is just 5/6. Power of 4. So I get 1/6 and then I get 4 non-6s. And you put that in your calculator. So 5 choose 1 times 1/6 times 5/6 the power of 4. I get here 3125 over 7776, or roughly equal to 0.4. So I have a 40% chance, basically, of getting 1/6, exactly 1/6. Right? Now, what about 3 6s? What's the probability of me getting exactly 3 6s? Well, my number of trials is still 5. I throw a dice. So I want 3 6s, so 3 successes. Probability of getting a 6 on a die is 1/6. I want it to happen 3 times. And then the probability of not getting a 6. So I want that to happen twice. The probability of getting 3 6s is equal to 125 over 7776, which is roughly equal to 0.016. So I actually have a very low chance of getting that. Then the last one here is the probability of at least 1/6. So the probability of at least 1/6. That means I can get a 1, I can get 1/6, I can get 2 6s, 3 6s, 4 6s, 5 6s, or 6 6s, right? But a bit of an effort to calculate the probability of getting 1/6 plus the probability of getting 2 6s plus the probability of getting 3 6s, 4 6s, 5 6s, etc. So usually, if we ever see the word at least, right, at least 1, right, what we do is 1 minus the probability of getting no, right? So that would be 1 minus 5 choose 0, 1 over 6, well, I want 0 6 to happen, over 5 over 6, and I want that to happen 5 times. So 1 minus all of that is going to be equal to 4 6 5 1 over 7 7 7 6, or roughly 0.598, right? So the probability of getting at least 1, right? Probability of getting at least 1/6 would be 0.5. Okay, look at this one here. Joe plays basketball. Probability he makes a free throw is 2/3. Suppose Joe shoots 8 free throws in a game. Solve the following. The probability he makes exactly 6 free throws. So he makes exactly 6. So in the 8 free throws he does, he scores 6 times. We times that now, the probability of success. He makes a free throw 2/3 of the time. We want him to get exactly 6 of them. And then how many times does he miss? Well, the probability of missing is 1/3, and he misses then twice. So remember that these powers must add up to this number here. 6 plus 2 is 8. Put that in your calculator, and you should get roughly equal to 0.27. So he has 27% chance of getting 6 of his free throws. Probability he makes at least 6 free throws. Free throws. So at least 6. So the lowest he can make is 6. So he can make 6, 7, or 8. Right? 6, 7, or 8. So that would be the probability he scores 6, the probability he scores 6, probability he scores 7, and the probability he scores 8. Add them together. So we know this one. This is 0.27. We just calculate there. The probability he scores 7. So out of the 8 free throws, he scores 7. That'll be 2/3 to the power of 7 times 1/3 to the power of 1 plus 8, choose 8, 2/3 to the power of 8 times 1/3 to the power of 0, because we want him to score 8 times. And if you put this in your calculator, you get 0.27 plus 0.186 plus 0.043. Add them up, you get 0.468. So what's the probability he makes at least 6 throws? Is 0.468. The next question here is the probability he makes. This one's a tricky one. The probability now he makes at least 6 free throws in 3 successive games. So he plays 3 games in a row. What's the probability he makes at least 6 free throws in them 3 games? Well, the probability he scores at least 6, right, is 0.468. We want that now to happen for 3 games. So in the first game, he scores that. In the second game, he does it. Right? So he gets at least 6 in the first game, and at least 6 in the second game, and at least 6 in the third game. So we're going to be multiplying probabilities together. And that will be equal to 0.1. The fourth question here now. The probability he makes his 6th free throw on his 8th try. Okay? So this is a tricky one. So we want to imagine now he's doing his 8 free throws. But we want to now calculate probability. What's the probability he does his 6th one on his 8th try? So that means for the first 7, he only scores 5 times. Right? For the first 7, he only scores 5 times. And he misses twice. That's the first 7 goes. And then for the 8th go, so for the first 7, he scores 5. And for the 8th go, he scores the 6. So we multiply then by 2/3. So that's his first 7. That's his 8th. Put that in your calculator, and that would be equal to roughly 0.12. And the last part here, is in a string of 5 games, what is the probability he scores at least 6 free throws in 3 of them? So now, in 5 games, what's the probability he scores at least 6 free throws in 3 of them? So, what's the probability of success? Well, the probability of success, so I call that P. P is my probability of success. What's the probability he will score at least 6? That is 0.468. What's the probability he won't score 6? At least 6. Well, that's 1 minus that. So 1 minus 0.468. That is 0.532. So the probability in one game scoring at least 6 is 0.468. And the probability of scoring not scoring at least 6 is 0.532. So now we're doing this for 5 games. So in 5 games, we want him to score 6 at least 3 times. 0.468 power 3. And that means in the other 2 games, he doesn't. We put that in a calculator. 5, choose 3. That's 0.468 to the power 3. That will give me roughly equal to 0.29. I see roughly around a 29% chance of doing that for 3 games in a string of 5. Right? And that was kind of my harder example there of Bernoulli trials. Right? So I'll wrap it up there for this video. In the next video, we'll be looking at some exam questions then for Bernoulli trials. I hope this video was some help to you guys, and I'll catch you guys later. Bye.